All right, in this podcast we're going to talk about reactions, which is really what chemistry is all about, right? Creating new substances. All right. So we've been talking about the 4 signs of a chemical change. Now, a chemical change occurs when a new substance is formed. Bonds are broken, bonds are formed. So the first one is formation of a precipitate. A precipitate is a solid formed during a chemical reaction. So usually the reason we call it a precipitate is it's kind of like snow. We have 2 liquids, let's say, that mix together, and you see it almost looks like snow forming coming down, and a solid will form at the bottom of the test tube. Now, you will also see sometimes just cloud. If you have 2 clear liquids and you mix them together and they're cloudy, you also have a precipitate. It's just that the solid is suspended in the liquid and obscuring the light, which is why it looks cloudy. Okay. The other sign of a chemical change is formation of a gas, which is usually seen as bubbling. Sometimes it can be observed as odor, but what's happened is you have formed a new compound, and that compound happens to be a gas, and when a gas tries to leave a liquid, it causes bubbles as it's escaping. Now, color change is also a sign of a chemical change because you have something new in your test tube, evidenced by the new color, something that was not there before. So the substance isn't changing color. You have formed something new, and that new material has a color to it that is different than the other materials. Temperature change is also an indication that you have a chemical change. And when I talk about temperature here as an indicator of chemical change, I'm not talking about taking something and putting it on a hot plate. I'm talking about if I have let's say 2 liquids at room temperature and I mix them together and they get hot. That's a temperature change caused by the chemical reaction. Okay. All right, so let's talk a little bit about energy and reactions. There's 2 ways to describe what's going on with energy. One is exothermic, exo meaning to leave or to exit, thermic applying to temperature. An exothermic reaction is a process that releases energy as heat or light. So it's not always heat. It usually is heat, but it could also be light, like on a flame, or even a light bulb. Okay, and then endothermic would be the opposite. Endo means to go in. Okay, so it's a reaction or process that absorbs energy as heat. Now, these processes, these terms imply to either reaction or processes. So this is not just happening in chemical reactions, but you can have them happening in phase changes too. So let's just talk about which of these might be exothermic or endothermic. So making ice cubes. So if you're making ice cubes, you're removing the heat from the ice, and the ice is getting if you look at indication of what's going on when you're making ice, what you'll notice in your kitchen is your kitchen actually gets hot behind the refrigerator. The energy leaves the freezer through the coils in the back of the freezer, and it's actually getting warm in the room. So making ice cubes is an exothermic process. Melting those ice cubes, I need to put energy into the ice cubes to get them to melt. So that is an endothermic process. A candle flame, here we have both heat and light being emitted, so we therefore have an exothermic process. Baking bread, I have to put energy in to make the reaction occur, so that is an endothermic process, just like cooking an egg would be. Burning sugar is a little bit different. I'll do a demonstration one day soon where we see sugar burning. The process of burning sugar actually creates a tremendous amount of heat. Even though you've got to put heat in, it gives more heat out, so it's a very exothermic process. Okay, during this reactions unit, a lot of times we're going to have a word equation. I'm going to say something like aluminum reacts with oxygen to make aluminum oxide. And we're going to have to convert that word equation to formula equation. So just a couple of things to keep in mind is we are going to follow nomenclature rules, right? So if we say aluminum chloride, that means aluminum with chlorine. Aluminum's a +3, chlorine's a -1, so that formula is AlCl3. That's what we talk about with nomenclature rules. We still have to have balanced formulas. We need to know the 7 diatomics. And if you look on your periodic table, and remember they make a 7, nitrogen, oxygen, fluorine, chlorine, bromine, and iodide, and they point to the 7th, which is hydrogen. So, for instance, if we talk about decomposing water to produce hydrogen and oxygen, we'd write it like this. We'd write water makes H2 plus O2. Now, this isn't balanced, and we need to do some things like make that 2 and make that a 2 to make it balanced. But you have to write hydrogen and oxygen with a 2 subscript. Now, we only do that when it's an element, when it's by itself. Here in the water, the oxygen doesn't have the 2 subscript. Okay. We also need to recognize acids, and the way to recognize them is they start with an H, and their names end with the word acid. Let's just review acid naming. So HCl, it's binary acid, so it's hydrochloric. HNO3. NO3 is a nitrate ion, so we form nitric acid. This is the sulfate ion, so we form sulfuric acid. This is the sulfite ion, so we form sulfurous acid. Remember, X and eights and ites and us. Here we have the phosphate ion, so we form phosphoric acid. Here's acetic acid, so we form, the acetate ion, so we form acetic acid. There's a carbonate ion, so we form carbonic acid or carbonic acid. Okay, that's going to stop us right there.